Hello and welcome to another one of D's ADD videos. Today we're going to be looking at an example using the concepts of percent yield and limiting reagents. A quick review. The first thing we must do is calculate the theoretical yield. And in order to do so, we must know what the limiting reagent is. And there are a couple ways to do so. We're going to go over one of them in this video. And you can choose your favorite way and use it, or use one way to do it and then use the other way to check it. However you want to apply the knowledge is up to you. And we're going to use stoichiometry using the coefficients of a balanced equation. It should be balanced. And you can determine the limiting reagent, which one's not in excess. And once you've gotten the one that's limiting, you can then calculate the theoretical yield from using stoichiometry. The actual yield will be given in your problem. It's an experimental piece of data that you record. You did an experiment and you got a certain amount of product. Theoretical yield we just calculated in step 2 over here. Let's see this in action. Here's a problem. We have 12 grams of phosphorus, right away, one reactant, and 35 grams of chloride. And when we mix those two, we got this much product. Right away, we've just found something. What did we just find? Well, we just found the actual part of our percent yield. That's the actual. We did an experiment, that's how much we got. For whatever reason, it's not the full amount, so we have to calculate the percentage yield as a result. So here is a balanced equation. Let's double check. 2 phosphorus, 6 chlorines, 6 chlorines. It's balanced. All right. So we got to figure out which one is limiting now. How do we do that? Well, there was 2 methods. This method is going to use the gram method. So we're going to start out with one reagent and try to get the other reagent. So it doesn't matter which one you start out with. Your interpretation of your answer is what's key. So here I'm starting out with the 12 grams, remember, of phosphorus I was given. I'm using the molar mass to convert phosphorus into moles. And then I can use what's called the mole ratio that allows us to convert from one thing to another. In this case, allows us to go from phosphorus to chloride. Now that we're in chloride moles, we can then go to grams of chloride by using the molar mass of chloride. Now, I want you to pay specific attention. I didn't use 35.43 because that's the mass of just one chlorine atom. I did twice that, or 4,5, whatever your periodic table says. So because it's Cl2, you have to multiply it by 2 to get the molar mass. And when you do so, all these units cancel and you're left with grams of chloride. What this is here is telling you how much chloride you need to react with 12 grams of phosphorus. So it's saying I need 41.2 grams of chloride, according to this balanced equation, to react with this 12 grams of phosphorus. Well, then you go back to your problem. Do I have enough chloride? No, I do not. I have 35 grams of chloride. What does that tell you? That tells you that chloride, as a result, is the limiting reactant. We did not have enough. So that also tells you that phosphorus is in excess. And if you wanted to, you could calculate the excess amount of reactant you have here. That's a different example video altogether. So let's see what's going on now. I have calculated which one is limiting. So now I start with the 35 grams of chloride and figure out how much I should have theoretically according to my balanced equation. So it's more stoichiometry. So we started off with 35 grams of chloride. Now we need to figure out how much theoretically we should obtain of this phosphorus trichloride product here. So if I start out with 35 grams of the chloride. What do I need to put on here? Well, grams of chloride so they can cancel and give me moles of chloride. Remember, there's 2 chlorines, so multiply your molar mass of chlorine by 2. Now use the mole ratio of the balanced equation. This is just the coefficient, right? If you look up top, the coefficient of both of those. So if you look at this balanced equation, that 2 came from right here for the phosphorus trichloride. And then the 3 came right here from the chloride. So then you use the molar mass of PCl3. So if you look up phosphorus on your periodic table, you have 30.974. Chlorine is going to be 35.453 times 2. Add all that together, you get this value of 137.3 grams of the phosphorus trichloride. When you multiply all this out and cancel everything, you're left with units of grams of phosphorus trichloride. Why is this important? This is telling you your theoretical yield. That's what we were looking for. In order to calculate our percentage yield, which is going to be the actual over the theoretical, times 100. So the actual, where did we get this 42.4 grams from? That was, if you remember at the very beginning of the problem, given to us. That's the actual amount. We just calculated the theoretical amount. That's 45.2 grams. So now you take the ratio of the part over the whole to get the proportion or the fraction, and then multiply it by 100 to get the percentage. Okay? So this is actually pretty good. You got 94.8% of the product that you were supposed to get. There was only a little bit of deviation from what you expected. So that's a basic example of percentage yield. Make sure you practice these. Like I said, there are other questions they can ask you besides what is the limiting reactant, what is the theoretical yield, what is the percentage yield, how much excess do I have of the reagent that's in excess. All these things could be asked of you. Check out the more advanced video. We'll go over all that. And I will do another video that will show you this same problem that we just did. And I'm going to use the molar approach to it. Okay? Use moles. And basically what I'm going to be doing there is taking the ratio of moles of product to each one of these reactants. All right? So practice, practice, practice. Thank you, and have a nice day.